Hello and welcome to another math video. Today we're continuing our work with our FSTA final study guide. We begin with simplifying some exponential expressions. When we do that, of course, we do want to make sure that there are no negative exponents in that. Fix this quick here. And we're going to assume that all variables represent non-zero numbers for this. Now there's a few ways we can get started here. We've got the -2 for the exponent here, of course the -3 for the exponent there. Of course we always want to deal with negative exponents, but not necessarily always right away. What I would look at here is that inside this fraction in the parentheses here, we've got t's in the numerator and t's in the denominator. So I would begin with that, where really the t to the -3rd in the numerator would drop down to the denominator in order to have a positive exponent. And since there's not much out here, I'll just go ahead and pull this t to the 3rd up since it had a negative exponent in the denominator. And since I'm going to have a fraction on the left, I'm just going to keep that as 17t to the 3rd over 1 so that I've got a fraction on the right. It can just be easier to look at and keep track of. Next thing I would do there would be to just kind of put together the t to the 3rd and the t to the 5th, get t to the 8th. Again, we're adding those exponents there when we're multiplying those t to the 3rd and t to the 5th together. Now I'm ready to go ahead and deal with the negative on that fraction on the left there, that -2. But I'm just going to take care of the negative first and leave the 2 alone. So the negative is going to flip that whole fraction over. And I just find that it's easier to do that just kind of one piece at a time. I'm going to go ahead and move up here. Now I'm going to go ahead and just square the t to the 8th over 15. So both the t to the 8th and the 15 get squared when we do that. And what's going to happen there is, of course, when it's a power of a power, you multiply the exponents together. So we get a t to the 16th from the 8 times 2, and then 15 squared is 225. I'm going to multiply that by 17t cubed over 1. So you can see now why I want to just keep that fraction, just to make it clear that the 17t cubed is in the numerator and there's really nothing of consequence in the denominator there. At this point, when we multiply those fractions together, we're going to have a 17 in the numerator, and then the t to the 16th and t to the 3rd would multiply together. That would add those exponents, so we get 16 plus 3 is 19, and of course 225 times 1 is just 225. 17 and 225 don't reduce, 17 being a prime number, its only factors are 1 and 17, and 17 not a factor of 225. So this is what we're looking at for the answer there. In the past quizzes and tests, this was one of the toughest questions we had, so feel free to watch this a little bit, a couple times even. All right, for 36, we've got a similar question. Same sort of thing with simplifying the exponential expression. In this case, we've got the whole numerator, 3x to the 5th, y to the 2nd to the 6th power. So that whole thing to the 6th power, and then just the 9xy squared in the denominator. So key here is that we cannot reduce like the 3 and 9, or the x to the 5th and the x, or the y squared and the y squared. We can't reduce those at this point because we have to take care of this exponent in the numerator first. So we take all of that stuff in the numerator to the 6th power. Now, there's a few ways to look at this, and I'll kind of maybe explain all of those, but 3 to this, oops, get my pen back here, 3 to the 6th, and I'll just leave it like that for a second, and then x to the 5th to the 6th power. Again, we would multiply the 5 and 6 together, so we get x to the 30th, multiply the 2 and 6 together, we get y to the 12th, and then in the denominator we just have the 9xy squared. Again, the denominator not being taken to the 6th power there. Actually, let me do this. So one way to look at the 3's and the 9's, and it's just kind of because this works out, is kind of change the 9 to be a 3 squared. Then we can just kind of treat that just like we would if it were x to the 6th over x squared. So we end up getting 3 to the 4th in the numerator, And then we would subtract the exponents on the x's. We have a 30, and then there's really a 1 there. There's more on top, so those end up in the numerator, so x to the 29th. And then same thing with the y's. 12 minus 2 would be 10. That ends up on top because 12 is more than 2. We get y to the 10th. And then just finally, the 3 to the 4th would be 81, and then x to the 29th, y to the 10th. Again, with the 3's and the 9, a different way you could do that is you could just figure out that 3 to the 6th is 729, and of course the 9, and that would also give you the 81. And of course the x's and the y's wouldn't change at all. So just depending on how you want to do that, it's not too common where that kind of thing happens, but if it does, you can kind of handle that either way. Moving on to number 37, expressing the number in scientific notation. So we start by writing this 5,607,000. We start with a number that's between 1 and 10, so 5.607, putting that decimal point just right after the first digit. And then we multiply that by 10, and then we need an exponent there. Some people like to do their loops and count how many things there are there. For me, what I look at is it's a 7-digit number. We put the decimal point after one of those, so we really moved that 6 places. So a 7-digit number will have a times 10 to the 6th in scientific notation. If you like your loops, which I don't, 1, 2, 3, 4, 5, 6. Oops, did I do that wrong? Oh, no, I did. Okay, so we're supposed to get 6. That's right. So see, again, that's kind of what I mean too. It's just it's I don't know. It's weird to me to do the little loopy things. I don't even like them. But you know, that's how that works. If you're used to that, you can stick with it, of course. But I like the idea of just, it's a 7-digit number, so in scientific notation it'll be times 10 to the 6th because we put the decimal after the first digit. Same sort of thing, we've got the number in scientific notation. We want to put that in standard notation. So what I look at here is it's times 10 to the negative 4th. So I know it's going to be a small number because it's got a negative exponent. And then the negative 4 tells me that there's a total of 4 zeros when I write this properly. And by that I mean including the 0 in front of the decimal place. Sometimes people get lazy, don't want to write that down. But if that's there, then it has the same number of zeros as that exponent. And then we just have the 197 from our number that we started with. And so that's that number in standard notation. And then switching gears a little bit here, finding the requested value. So they give us the function f of x is negative 8x squared minus 10x plus 3. And they ask us to find f of 2. So really when we are finding f of 2, all we do is put the 2 into this function for all of the values of x. And then we just evaluate. So we can do a little bit at a time here. The 2 squared, of course, would be 4. 10 times 2 would be 20. 8 times 4 would be 32. So we've got a negative 32 there, minus the 20 plus the 3. I would go negative 52 plus 3. So it's really like taking 3 away from 52. We get negative 49. For that. So f of 2 is negative 49. That's what they're looking for there. And of course, I mean, you could do more than a little bit of that on the calculator, but again, you got to be careful with typing that stuff in. Sometimes people make silly mistakes with that. Same sort of thing, working with functions. Here we're starting with f of x and g of x, and we're finding f minus g of x. Really all that is taking that function f of x, which is 4x minus 3, and subtracting the function negative 8x plus 10, which is our g of x. Again, the key here is making sure that we actually subtract both of these. Very often people will remember to look at this and say, oh yeah, we're really adding 8x. But then they'll forget to do that over here, and they'll put plus 10. And it's like, well, no, you're subtracting that 10. So really it's minus the 10. So 4x minus the 3 plus the 8x minus the 10 is really what we end up with after we take care of the subtracting there. So 4x and 8x ends up being 12x, and then a minus 3 and a minus 10 ends up being minus 13. 41, same sort of deal, except now we're adding, so if anything, a little bit easier. We just take that function f of x, and we add the function g of x, and we just combine like terms. So we have an x squared and a negative 7x squared, so it'll lead us to a negative 6x squared. We have a 4x and a 7x, so that will give us a plus 11x. And we also have a minus 4 and a minus 5. That'll give us a minus 9 for that one. So that's what we're looking at there. Negative 6x squared plus 11x minus 9 for those. Here we've got a composition of functions. So again, I want to emphasize this dot here, or circle really, is a composition circle, not a multiplication dot. This is saying find f of g of 3. Personally, I prefer the old school way of writing that. I believe it's a little bit more clear as far as what you're doing. So we really find g of 3, and then we use that as the input into f. So g of 3 would be just 3 plus 8. So g of 3 is 11. And so then I'm really finding f of g of 3, but now I know that g of 3 is 11, and so we know we've got 6 times 11 plus 4, so 66 plus 4, or 70. So that's what f of g of 3 is, really it's 70. Number 43, and this will be the last one for this video. The same sort of idea, but it's f of g of x. So we can't really find g of x, although we already know what g of x is. G of x is x squared minus 9. And again, I do prefer kind of the old school way of looking at this, finding f of g of x. Well, g of x is that x squared minus 9, like I already said. So finding that f of x squared minus 9, all we do is replace all the x's in f of x with x squared minus 9. So you can see here how it's really 4 times the input plus 5, which is what our f function is, 4 times x plus 5. Just in this case, instead of x, we have x squared minus 9. So we do a little distribution. We get 4x squared minus 36 plus 5. So we get 4x squared minus 31 for our f of g of x. As always, thanks for watching, and hopefully you found this to be helpful.